So dear students, we will start today with the chemical analysis of water. Now in the chemical analysis of water, the first analytical method, that is determination of sulfate by gravimetric method. Now what is meant by principal gravimetric method? So gravimetric method is the procedure of precipitating the metal or anions and estimating the weight of the compound formed with respect to the atomic weight of the metal or anions. So it is the converting either the metal or the anions in terms of a compound, and from the weight of the obtained compound you have to calculate back the what is the weight of the metal which is present in the solution. Now in the determination of sulfate by gravimetric method, let us consider the sulfate anion SO4 2- present in the water. Usually this SO4 2- present in the water in the form of a sodium sulfate, magnesium sulfate, calcium sulfate, etc., and which causes the hardness, you know that. So this sulfate will be estimated. How it will be estimated? So to the known amount of water sample containing SO4 2-, which is added with excess of barium chloride in presence of a concentrated HCl. So in presence of acidic medium, excess of barium chloride is added and completely precipitated the sulfate in the form of a barium sulfate. So from the amount of barium sulfate formed, how much is the amount of SO4 2- present in the solution is calculated. The precipitate was dried and weighed as a weight by weight ratio. How much weight of the barium sulfate formed, and from how much weight of the sulfate anion is present in the solution. So the reaction, when you look into the reaction, so the sulfate SO4 2- present in the water. This SO4 2- reacts with excess of barium chloride in presence of acidic condition and completely get precipitated as a barium sulfate, and the obtained barium sulfate is filtered, washed with water and dried in a crucible. Before taken into the crucible, this weight of the precipitate, empty weight of the crucible is noted. So after continuous drying, all the water, when it gets evaporated from the barium sulfate, weigh the crucible along with the precipitate and subtract the empty weight of the crucible, you will get the weight of the barium sulfate. From the weight of the barium sulfate, how much is the amount of SO4 2- present in the solution is calculated. So that is the principle of sulfate by gravimetric method. Now what is the procedure? So usually the procedure involves 200 ml of the test solution, in which the sulfate content was to be measured by gravimetric method, test water sample. If it is turbid, filter the solution. 200 ml of the test solution is taken into a beaker, added with a few drops of concentrated HCl to make the solution acidic, and it is boiled. 200 ml will be boiled to reduce the volume to 50 ml. So this boiling involves the making the sulfate concentration. So increase the sulfate concentration. Removal of the excess of water will increase the concentration of sulfate. It will help in the precipitation process. So the boil the solution, entire solution, and reduce the volume to 50 ml. Now this hot solution of water sample added with hot solution of barium chloride solution, 10% aqueous barium chloride hot solution is added dropwise, slowly with the constant stirring. Still all the sulfate ions which is present in the water is precipitated as barium sulfate. Now 1 or 2 drops of excess barium chloride is added, and avoid adding excess of barium chloride. Do not add excess of barium chloride, which very excessive barium chloride. Then entire precipitate is little digested for few minutes, and the precipitate is filtered and filtered in an Buchner funnel or a normal filter paper. Wash with the precipitate. Wash the precipitate with the hot distilled water until all washings are free from chlorides, and the precipitate is dried in an pre-weighed crucible, and the weight of the crucible is noted. Now, from the weight of the precipitate with crucible, the weight of the precipitate inside the crucible minus empty weight of the crucible will give rise to a weight of the barium sulfate forms. So, from the weight of the barium sulfate which is obtained by converting sulfate anion present in the water sample as barium sulfate by adding excess of barium chloride, we will come to know how much sulfate is present in the water. So, what are observations and calculations? 233.3 gram of barium sulfate molecular weight put together. So 233 gram of barium sulfate contains 96.0 gram of sulfate anion. So sulfate anion molecular weight is 96. Barium sulfate molecular weight is 233.3. So 233.3 gram of barium sulfate, which contains 96.0 gram of sulfate anion. Therefore, let us consider W gram of barium sulfate contains. So W into 96 divided by 233.3. Now W is the weight of the barium sulfate. This weight of the barium sulfate can be obtained from subtracting weight of the precipitate with the crucible and minus empty weight of the crucible. That's equal to weight of the precipitate. That weight, the percentage of, how do you calculate percentage? So W into 96 into 100 divided by 233.3. So this factor, if you multiply with 100, you will get percentage of SO42 minus sulfate anion, and which will be expressed in gram per dm cube. So if you want to express in ppm, so multiply with 1000, 100 into 1000 is 10 raised to 6. So that will give rise to W into 96 into 100 into 1000 divided by 233.3, that will give you milligram per dm cube. So percentage of sulfate anion as well as in the ppm, milligram per dm cube, that is nothing but ppm, can be easily expressed with the help of gravimetric method. So this method of is called as gravimetric method. Gravimetric method is the method wherein metal free metal atom or a metal ion or maybe an anion will be converted into a corresponding compound. That compound will be weighed, and from the weight of the compound, amount of anion or the metal ion is calculated. So is estimation of fluoride by colorimetric method. So you have done the you have not done the colorimetric method. So colorimetric method is what is the principle of estimation of fluoride by colorimetric method? Now the principle is zirconium spandas. So that is what is called as SpANDS. SpANDS is an organic compound, and which is made it in the form of a coordination compound, that is called as zirconium SpANDS. Is a red colored solution. So, and if this red color solution is added to the solution containing fluoride ions, so the red color will go on diminishing. So red color go on decreasing as the fluoride concentration in the solution increases. So releasing spandas into the solutions, and different molar concentrations of the test solution is prepared, and absorbance will be noted with the help of a colorimeter. This absorbance will go on decreases because the red color complex zirconium spandas will diminish its color as the fluoride concentration increases. So from the unknown solution, so unknown solution is also done with the same experiment, added with the zirconium spandas, and absorbance is noted. From the absorbance of unknown solution, concentration of fluoride is calculated. Now the reaction, when you look into the reaction of estimation of fluoride by colorimetric method, zirconium spandas, zirconium SpANDS, zirconium coordination compound it is. So this looks in red in color. This will be very blood red in color. Now this reacts with 6 fluoride ions, 6F minus, in water. So this fluoride will be present in water. So it forms a zirconium F62 minus I. So this complex zirconium F62 minus is a colorless anion. So more the concentration of the fluoride, more will be the formation of the colorless anion and less will be the absorbance of the solution. So absorbance here, instead of increasing in the normal colorimetric method, absorbance value goes on decreasing as the fluoride concentration goes on increasing. So as the fluoride concentration goes on increasing, it reacts with more and more zirconium spandas reagent, decreasing the color of zirconium spandas and forming a colorless anion of zirconium F62 minus and releasing spandas into the solution. Now this is the reaction which is taking place in the estimation of fluoride by colorimetric method. Now how the procedure is followed. So procedure of the experiment, a series of standard solution is prepared. Standard solution of fluoride was prepared. Standard solution of fluoride was prepared by using sodium fluoride in a 50 ml volumetric flask. So 50 ml volumetric flask, each of the flask is added with 1 ml, 2 ml, 3 ml up to 5 ml. 5 test standard solution is prepared using sodium fluoride, and to each of the volumetric flask added with one volumetric flask added with 1 ml, second volumetric flask with added with 2 ml, 3 ml, likewise 5 volumetric flask 50 ml capacity. To each of the volumetric flask 10 ml of red colored zirconium spandas solution was added. So in each of the volumetric flask 10 ml of red colored zirconium spandas solution was added, along with the addition of 2 to 3 drops of HCl, because this colorless anion formation takes place in presence of an acidic condition. So you have to add 2 to 3 drops of concentrated HCl and 1 to 2 drops of sodium hydrogen sulphide to stop the interference of chloride ions. If at all the water containing fluoride also contains chloride, so you have to stop the interference of these chloride ions by adding 1 to 2 drops of sodium hydrogen sulphide into each of the 5 volumetric flask, which is making it as a standard solution. First you have to prepare the standard solution. Standard solution is prepared by adding 1 ml of sodium fluoride solution in one volumetric flask, 2 ml of sodium fluoride solution in second volumetric flask, 3 ml, likewise 5 ml of sodium fluoride is added to 5 different volumetric flasks. Along with this 5 ml, all the 5 volumetric flask is added with a fixed quantity of 10 ml zirconium spandas reagent, with all the volumetric flask is added with 2 to 3 drops of concentrated HCl to make the water acidic, and 1 to 2 drops of sodium hydrogen sulphide to stop the interference of chloride ions. And once it is done, it is diluted up to the mark in the volumetric flask. So diluted up to the mark with the distilled water and make it as a 50 ml and shaken well. Now after the making 5 different standard solution, absorbance of these standard solution is noted, which is recorded at 570 nanometer using a colorimetric instrument. Colorimetric instrument wherein a small cuvette will be there. In that cuvette, the 1 ml of the test solution is taken and kept, and absorbance is noted. Here you have to see one condition: as the fluoride concentration increases 1 ml, 2 ml, 3 ml up to 5 ml, absorbance value goes on decreasing because it reduces the intensity of absorption of the red colored zirconium spandas solution. Now absorbance of each of the volumetric flask is recorded at 570 nanometer. Now a graph is plotted. Graph is plotted with the observed absorbance from the standard solution as well as concentration of fluoride ions. Concentration is known here. 1 ml of sodium fluoride is diluted to 50 ml, that is 1 by 50. 2 ml is diluted to 50 ml, 2 by 50, 5 by 50, so on. So likewise you can easily find the concentration of fluoride ion on the x-axis. Absorbance is the value which you are noting down on the y-axis. So the graph which is straight line you will get, which the decreasing graph. Now the in the fourth step, unknown or a test solution is taken. The test solution is taken, added with same 10 ml of zirconium spandas solution, 2 to 3 drops of HCl, and 1 to 2 drops of sodium hydrogen sulphide, and diluted to 50 ml, and absorbance is recorded. So the same procedure is done for the test solution whose concentration of fluoride needs to be detected. So the unknown solution is taken, and which is added with the 10 ml of zirconium spandas solution and 2 to 3 drops of HCl, followed by 1 to 2 drops of sodium hydrogen sulfide, and it was diluted to 50 ml, and absorbance is recorded. A calibration graph is plotted. Now let us say this is the absorbance of the unknown test solution. So from the absorbance, plot the line which will intersect the state line of the standard solution and extend that line to the x-axis. At the x-axis, you will get the concentration of fluoride ions present in the test solution. So a calibration graph is plotted with the absorbance against concentration of fluoride ions. With this graph, with the decreasing straight line, from the absorbance of the unknown solution, the line is extended to the straight line. From the straight line, it was further extended to the x-axis. So from the x-axis, the concentration of fluoride ions is calculated. So this is the procedure for calculating the concentration of fluoride ions by using colorimetric